Today we'll be solving 2008 AP Physics C Mechanics Free Response question. The question reads, a skier of mass m is skiing down a frictionless hill that makes an angle theta with the horizontal, as shown on the diagram. The skier starts from rest at time t equals 0 and is subject to a velocity-dependent drag force due to air resistance in the form of F equals negative bv, where v is the velocity of the skier and b is a positive constant. Express all algebraic answers in terms of m, b, theta, and fundamental constants. Part A. On the dot below that represents the skier, draw a free body diagram indicating and labeling all the forces that act on the skier while the skier descends the hill. So the first force that we're going to write down is one that's going downwards, and that's mg. Now, perpendicular to the hill, we have the normal force going upwards. And going up on the hill, you should have a smaller drag force. Now, part B. Write a differential equation that can be used to solve for the velocity of the skier as a function of time. The easiest thing to do here is to do the sum of the forces in the x is equal to ma. Now, we already know that one of the forces is the drag force going backwards on the hill, but we need the x component of the weight vector. So to do that, we go up here, and since weight is going downwards and drag force is going back up, you have normal force going up here, it's easiest to shift the coordinate axis to deal with these two. Since the angle over here is theta, and this over here forms a 90-degree angle, this must be 90 minus theta. That implies that this angle over here is theta. So in order to get the x component over here, which is here, v of x, just the x, you need sine, opposite over hypotenuse. So here you get the sum of the forces in the x is equal to mg sine of theta minus bv. Now, we know that acceleration is equal to dv dt. So the differential equation we get is mdv over dt is equal to mg sine theta minus bv. So that's part B. Now part C. Determine the expression for the terminal velocity of the skier. So at v is equal to vt, acceleration is equal to 0. Therefore, mg sine theta minus bv terminal is equal to m times 0, which equals 0. So mg sine theta is equal to bv terminal velocity. Now you solve for terminal velocity and you get that terminal velocity is equal to mg sine theta over b. Now the final part asks to solve the differential equation we found before in part B to determine the velocity of the skier as a function of time, showing all our steps. So the first thing to do is write down the differential equation we received before. mdv over dt is equal to mg sine theta minus bv. The first thing to do is do separable variables, which gives you dv over mg sine theta minus bv is equal to dt over m. Now, we want to integrate both sides to find velocity. So we take the integral of dv over mg sine theta minus bv is equal to dt over m. But mg sine theta minus bv is a sort of ugly number to integrate. So we do u substitution and set u equal to mg sine theta minus bv. This implies that du dv is equal to 0 minus, you take the velocity, you bring down the 1 here, so you get minus b, and this becomes 0. So velocity goes away and you just get 0 minus b. So du dv is equal to negative b. So dv effectively is equal to negative du over b. Now we go back here and we substitute the values we received. So we received the integral here, mg sine theta minus bv as we found before becomes u. So now you have 1 over u, and dv we substitute for negative du over b. So, now, what we want to do is bring out the constants. Negative 1 over b is a constant, so you can bring that out. And 1 over m is also a constant, so you can bring that out. Now, divide over negative 1 over b to put all of the constants on one side. And we know that the integral of 1 over u du is equal to the ln of u plus some sort of constant, which we'll call constant 1. And that's equal to negative bm times t from this integral plus another constant, which we'll call constant 2. We subtract over the constant and we get ln of u is equal to negative b over mt plus c2 minus c1. Now, let c3 equal c2 minus c1. So, ln of u equals negative bmt plus c3. And now, we can let ln of c be equal to c3. So, ln of u is equal to negative b over mt plus ln of c. Subtract that over, and you get ln u minus ln c equals negative b over mt. Now you can raise both sides to the e. So e to the ln of u minus ln c equals e to the negative b over mt. Now when you're subtracting two lns to a power, you can do e of the first divided by e to the second one. Now these cancel out, and all you're left with is u over c, and you can multiply the c over. So you find out that u is equal to ce negative bt to the negative bt over m. Now we can subtract back, we can put back what the value we had for u, which was mg sine theta minus bv. So down here, you get mg theta minus bv is equal to ce negative. Now, I'm just going to continue over here. Now, when we go back and read the question, they tell us that the skier starts from rest at time t equals 0. So this tells us that at t equals 0, v equals 0. So we apply initial conditions. This gives us mg sine theta minus 0 is equal to ce to the 0, which becomes 1. So mg sine theta is equal to c. So now we go back to our equation and we substitute c in for the value we now know it as. So you get mg sine theta minus bv is equal to mg sine theta times e to the negative bt over m. Now we subtract over mg sine theta to get negative bv is equal to mg sine theta e to the negative bt over m minus mg sine theta. Take out the common mg sine theta, so you get negative bv is equal to mg sine theta times the quantity of 1 minus e to the negative bt over m. And because we divide by the negative b, so we give a. And that's your answer. So we just solved the mechanics problem. That's all.